Okay, so what is the discriminant? Okay, well, we're going to pull up our quadratic formula here. Okay, x equals negative b plus or minus square root of b squared minus 4ac all divided by 2, right? And we are going to talk about a specific part, and that specific part is called the discriminant. Your discriminant is this part that is underneath the square root. And the reason that your discriminant is important is it is going to tell you how many solutions and what type of solutions a quadratic equation will have. So this is not something that's giving you an answer. You're not going to use this to be like, okay, x equals 2 and 5. Okay? You are going to use this to describe your solutions. And what I mean by describing your solutions is, I mean, you're going to tell me, are they real numbers?
Amy Cook, please come to the counselor's office.
You're going to find out if they are real numbers. Okay? You're also going to be able to find out if they are imaginary numbers. Oh, because remember we just talked about things underneath square roots, right? So we can either have real numbers come out of the square roots or we can have imaginary numbers come out of the square roots. So there are 3 types that you need to know for your discriminant. Okay? When your equation is the form of ax squared plus bx plus c, we are going to look at if your discriminant, which remember the discriminant is the part that is underneath the square root. Your discriminant is the part under your square root. Part under your square root. So if the discriminant is greater than 0, if the discriminant is greater than 0, what does it mean if it's greater than 0? That means that it's positive. If there is a positive number underneath the square root, you are going to end up with 2 real solutions. Okay? If your b squared minus 4ac is greater than 0, you end up with 2 real solutions. Okay, so what's an example where we were talking about that? Well, how about this problem right here? What was underneath the square root was a positive number. It was 53. Okay? We were able to get 2 real solutions out of that. Now, they weren't really nice solutions. It was like negative 1.86 and something else, but we still were able to get 2 real solutions out of it. So if there's a positive number underneath your square root, you will have 2 real solutions. Another case is, what if what's underneath the square root equals 0? Okay? What if what's underneath the square root equals 0? Well, that's not a positive number. That is just literally it equals 0. If that happens, you will have 1 repeated real solution. So the solution is still real. You still end up with 2 solutions, but the 2 solutions you have are the same thing. You end up getting the same solution twice. So an example like that would be the one that I messed up on the last video. 1x squared minus 16x plus 64. Okay? We ended up getting a 0 underneath the square root. There was a 0 underneath the square root. So we still set up our 2 equations, but since there was a 0 underneath the square root, we ended up just getting the same answer twice. Okay? And then your last one, and we haven't had an example like this, but this can happen as well. Okay? Let's say that you end up with a b squared minus 4ac being less than 0. Well, if it's less than 0, that means that there is a negative number. So if we end up with a negative number in our discriminant, that would mean we had a negative number underneath our square root. We still have 2 solutions, but if there's a negative underneath the square root, we have 2 imaginary solutions. We end up with 2 imaginary solutions. Okay? Now, we have not talked a lot about graphing parabolas. We've just kind of touched on it with our shifts and stuff. But the solutions that we are finding their x-intercepts. So if I am on this case where my b squared minus 4ac is greater than 0, and I have 2 real solutions, I have found a parabola that looks like this. It has 2 x-intercepts, and those 2 x-intercepts are my 2 real solutions. If I go through and I find one that has 1 repeated real solution, I only have 1 solution, but it happens twice. Those cases are going to be when your parabola comes down and it touches that x-axis. Okay? It's going to touch it at one spot, and that's it, and then it goes right back up. The vertex is on the axis. So then what happens when we have imaginary solutions? Our real solutions, they're real, so they give us x-intercepts. But if I have imaginary solutions, that means that I have a parabola up here, and that parabola is never crossing your x-axis. Okay? Now, I'm not going to ask you guys to graph any of those yet. Okay? We will save that for lesson 3.1. Okay? But that is important for you guys to be aware of. Now, what am I going to have you guys do when you guys are trying to find your discriminants? Okay? Well, we're going to give you guys equations like you have right here. 27x squared plus 3 equals 18x. 3x squared plus 11x minus 8 equals 0. 2x squared plus 6x equals negative 5. And all they're going to say is they're going to say use the discriminant. They're going to say use the discriminant to describe the roots. Roots is just the same thing as solutions. Describe these solutions. Okay, so again, we're not going to give the solution. You're just going to describe them. Okay? Now, before I can get going on this, I have to make sure it's in standard form, so I need to subtract 18x over. So I've got a 27x squared minus 18x plus 3 equals 0. Okay? What is my a in this case? That would be 27. It's just like when I'm trying to figure out the quadratic formula. My b is a negative 18. And then my c is a 3. Now, I don't need to plug this into the quadratic formula. Okay, we're going to use the discriminant. Remember, your discriminant is b squared minus 4ac. It's the part that's underneath the root. Okay, so b squared, so negative 18 squared minus 4 times a, which is 27, times c, which is 3. Okay, so I end up with 18 squared, which gives me 324, minus 4 times 27 gives me 96, times 3, whoops, I must have put that in wrong. 4 times 27 gives me 108, times 3 gives me 324. So 324 minus 324, well, that equals 0. Now, if that equals 0, what's our answer? Well, when our discriminant equals 0, your answer is that it has one repeated real solution. One repeated real solution. So my answer for this problem is one repeated real solution. And that's the answer. You're not given a number answer because all you're doing is you are describing the roots. Okay? Next one. It's already in equals 0 for me, so I'm ready to go. My A is a 3. My B is an 11. My C is a negative 8. So I'm going to plug that in. B squared, 11 squared, minus 4 times A, which is 3, times C, which is negative 8. Okay? I've got 121. And then I've got a minus 4 and a 3 gives me a negative 12. Negative 12 times 8 gives me a positive 96. Well, 121 plus 96, that is definitely greater than 0, right? 121 plus 96 is definitely going to be greater than 0. So if I find that my discriminant is greater than 0, meaning that it's a positive number, that would be a positive number, right? That's going to give me 2 real solutions. So my answer for my middle one here is going to be 2 real solutions. Okay? And then our very last one, we've got a 2x squared plus 6x minus 5. Again, get it into standard form first. 2x squared plus 6x plus 5 equals 0. Okay? My a value is a 2, b value is a 6, c value is a 5. So b squared, I'm going to have 6 squared minus 4 times a. My a would be a 2 times c, which would be a 5. Okay, so that's 36 minus 4 times 2 is 8, times 5 is 40. 36 minus 40. What is 36 minus 40? Well, that'd be a negative 4. That is less than 0. So remember, the discriminant is the part underneath the square root. I've got a negative underneath the square root. That means I'm going to have two imaginary solutions. Two imaginary solutions. And that is going to be your discriminant. Okay? On the first, on your own, it just wants you to use the quadratic formula to solve this. Second, on your own, okay, gives you your equation. It says, what is the value of the discriminant? So you're going to simplify b squared minus 4ac all the way down. And then, after you've simplified it all the way down, describe the number and the type of the roots. Remember, roots are just your solution.